We're going to be working through this example here, which says plot the data in the table below. So we have temperature right here, and we have the number of students wearing jumpers here. So obviously the temperature is going to be our EV, and the number of students wearing jumpers is going to be my RV. So this will be my X, this will be my Y. Let's just begin by plotting this data and see what it looks like. So we're going to come to our trusty CAS calculator here, and I've already populated this for us. So this is lists and spreadsheets. I've called this temperature. I've called this STU for students. And what we're going to do is go control, add doc. We'll go add data and statistics. This will be my, now let's make sure we get this right, temperature. And this one here will be my students. And as you can see, it is got a bit of a curve to it. So we need to make this more linear. How are we going to do that? Well, it tells us that we're going to be using a 1 on X transformation to linearize the data. So that means what I'm going to be doing is I'm going to be going 1 over the temperature to make this more linear. So let's come back to our CAS here. We'll go back to our lists and spreadsheets. I'm going to come here and I'm going to be finding the reciprocal of the temperature. So let me call it R temp. Then I'll come here, I'll go equals, and I'm going to go 1 divided by my variables. And the variable that I want is, now I need to find temperature. I've got way too many things going on here. There it is, temperature, 1 over the temperature. I hit enter. And there you go. You've got all of that there. So now if I jump back over here and change the temperature to the reciprocal temperature, let's have a look at what happens. Perfect. Now, a lot of things happened there. Well, 2 things particularly. First of all, it became more linear, which is fantastic. That was the whole point of it. But did you also see that the direction of it changed? If I go back to what it originally was, I've got a negative gradient going on here. But when I change it to the reciprocal, I now get a positive gradient. And that is the effect of using a reciprocal transformation. It will make it more linear, but it will also change the direction of it. So we have to take note of that. All right, then the next part of this question says the following, that we need to fit a line to the transform data with Y as the RV, 1 on X as the EV, and write the equation in terms of the variables. So I need a least square regression line. So what I'm going to do is go menu, I'm going to go analyze, I'm going to go regression, and I'm going to go show linear A plus BX. And there it is right there. So I'm just going to write this down in here. And I'm going to not use X and Y. Instead, I'm going to use temperature and number of students wearing jumpers. So if we come here now, I'm going to say that the number of students wearing jumpers is equal to negative 0.4, because that's what we see. Oh, it went away. What happened? If I go control Z, it comes back. Haha. At negative 0.4. Fantastic. And then the other number was 94.6. And then I'm timesing that by 1 over the temperature. This is important. This is the part that people mess up, is they don't write in their equation the reciprocal of it. So just make sure that you're writing it like this. Otherwise, you're not going to get the correct answer. People, what happens is they just read it straight off here. And they just go, oh, look, it's an X. I know that's temperature. But remember, you have to keep in your head that you've applied the reciprocal transformation. Okay, we keep on going. Use this equation to predict the number of students wearing jumpers when the temperature is 17 degrees. So what we're going to do here is I'm going to just replace this with 17. So I'm going to write it out again. I'm going to say the number of students wearing jumpers is equal to negative 0.4 plus 94.6 times 1 over 17. And again, you can see how people would mess this up. They wouldn't write it as 1 over 17. They would just write it as 17. But you've got to remember that you're using this formula that you've just created. So now we're going to come to our CAS. We'll go control, we'll go doc, we'll go add calculator. And I'm just going to type that in. So it's going to be negative 0.4 plus 94.6, and then I'm going to times that. Oh, what am I doing? Sorry, I wasn't even looking at what I was doing there. Nothing was coming up. My apologies. All right, let's try that again, shall we? All right, so it's, oh, do you know why? Because I have to hit this one. Negative 0.4 plus 94.6 times 1 on 17. All right, we have a look at that. That all looks good. We hit enter. And we're going to get that answer, 5.16. So that means if I was to round this to 1 decimal place, I'm going to end up with, if I grab a pen, 5.2. Therefore, this would be 5 students. So if the temperature was 17 degrees, we could predict using this right here that 5 students would be wearing jumpers. And that's it. That's how you use your reciprocal transformation to do what you need to do. Hopefully you found this helpful.